Today's tutorial, I'd like to show the example I'm using the bioinformatics toolbox in the MATLAB. So, I'll show the introduction. What is MATLAB? MATLAB is for the matrix laboratory, and it's do the numerical computation with the matrix and the vectors. But the company sooner integrate with the other computation visualization and the programming functions and become very powerful. But also easy to use. And it can be used for almost all the platform. ASU right now is holding a licensure, so all the students and the professors can the faculties can download the software and install for the analysis. But meanwhile, the MATLAB is also widely used in the bioinformatics and application. And they provide the function and analysis techniques for the sequencing, microanalysis, proteomics, and system biology. So MATLAB is actually holding holding all different kinds of a toolbox. It seems these toolbox are the individual, but they can work with each other to perform a multiple test. So let me bring the MATLAB environment. So this is a MATLAB environment, just like the spider for the Python. You can just type it here to do a single functions, or you can write your own syntax or programming if you want to say to perform multiple tests. So here is the script that I wrote saving in the files. And today's the example I'm going to show is how to visualize the three-dimensional structure of a protein. So this example, we're going to show how to going to show how to display, inspect, and analysis the three-dimensional structure of a protein. So if you have the live web connections, you can simply using these call functions to call the database with the certain proteins name you want to get in from, and assigns to this variable code, assigned to this variable, and using this variable holding this protein structural data set, and assigns to these more view functions to display the structures. So let me bring this. Now it's working on to it. So this is a Windows display the protein structure. This is a small protein called ubiquity. It only contains the 76 amino acids long, but it's very conserved in all the eukaryote cell system. So under the display, there's several options you can select by changing the different view of the frame. And by default, the protein structure indicates such each atoms is represented by the ball, and all the connection, as we call the bond, is represented by the stick. But actually you can change either by selecting the features below, or you can assign the parameter different parameter setting through this function called the evaluate mode script. This function is just like the on-call subroutines that are holding the protein structure characteristic information with all the parameter settings modification. So let's do the first one. The first one is I want to enlarge the connecting bond. So now you can see all the connecting bond is being enlarged. What about the next one? So the next one, I'm changing the display structure mode to the carton model, and also highlight with the colors according to their secondary structure assignment. So what is the secondary structure here? It's, it's like here pink indicates the helix, and the yellow indicates the paper sheet, and the purple is indicate a little bit coil fold here. This white wire line, it indicates there's no firm a structure that we can identify. We would just simply assign it as the white wire line over here. So the next exploration of this structure characteristic is we can rotating and zoom out this structure. So in the first in the first 180-degree rotating on the y-axis, we also keep zooming by 40s in the 5 seconds. But on the second 180 degrees rotating on the same y-axis, but we will just zoom out the 40. So here it's a minus 40 in the same time frame. So let's do the next characteristics, the modification. So this is the one showing all the amino acid charge distribution. So the red is indicate a positive charges, and where the blue is indicate the negative charges. All these small the white balls what we're showing here is indicate the water molecules that surrounding this protein. Okay, so let's bring back to this cartoon models of the protein display. So I want to see if I'm going to look into this this helix structure. Where's the starting amino acids, and where's the ending amino acids? Just by doing the assigns to the the initial procedure and the ending procedure. So they will indicate here is the starting procedure and here's the ending procedure. And also on this command lines also replies to the answer where is the position. So in the initial position is 23rd and the ending procedure is on the 34th. So in the next one, I want to calculate not only showing the initial and the ending procedure, but I also want to measure this length of helix and also this plate over here. So by assigning to the parameters, by assigning the different parameter to this evaluate small script functions, I can simply to measure the distance, to measure the length and the display over here. So here is a display 1.649 nanometers long in this helix structures. So the next one, I'm going to highlight the specific amino acid residue on this structure. And this specific amino acids I want to display is called the lysine. And so on this structure, the balls with the lines connected, it indicates where the lysine on the structure, and also labeled with the lysine and the position and all other different information associated with it. So this is a kind of a very cool a toolbox which can provide all the functions and to perform the bioinformatics analysis. And of course, this toolbox also provide other functions can performing all different kind of data analysis, which is microarray data analysis or the sequencing analysis, and all the different kinds certainly provide a wonderful tools for the biological research.